Hi guys. So today I'll be doing this. This is a question taken from a Cambridge pre-U paper or pre-U paper, which is most probably after your A levels. We'll be taking your A2. So yeah, today I'll be doing this. Is a base calculus question. It's a really calculus question. If you want to know, the code is taken from 9794. This is a May June paper. Then this is paper 2. Then paper 2, and then is a May June paper 2. Yeah, I think that's all. Alright, so anyways, let's begin. This is a really calculus question. So it says that the curve of the equation of a curve is x squared plus 2xy plus 3y squared equals to 18. Show that the equation of normal to C at the point 5, -1 can be written as 2x is equals to 2y plus 7. Right. So when it comes to thinking of normal, we will straight away think of differentiation. But in that case, usually if you're doing your IGCSEs, you'll realize that your differentiation is like y equals to something, then expecting you to differentiate it and dy dx. But in that case, it's giving us a equation C, which is x squared plus 2xy plus y squared, 3y squared is equals to 18. So in that case, we have to do something which I like to call implicit differentiation. So what does implicit differentiation do? Basically, when you have something like equation that contains like more than one variable, because in that case we have an x and then we have a y in the variable, we can actually take derivative from the both sides, dy dx from the both sides. From there we can actually calculate it. Okay, so how does it work? Let me show you. So what I'm gonna do, I'm gonna take d dx on both sides. I'm gonna differentiate both of them on both sides. So this will be d dx. So what's gonna happen? I'm gonna split, so d dx of x squared plus d dx of 2xy plus d dx 3y squared is equals to d dx of 18. So if you know your differentiation rules well, you will realize that it is a constant when you differentiate like a constant is going to be 0. So I can already say this is equals to 0. Alright, continue. d dx of x squared, we can use the product rule, 2x. So how do I differentiate this in respect to x when I have a y here? Well, considering y is a function, now you think about it, y is a function. So I have like a function multiplying by a function. So in that case, in this run, we can use product rule. Because you think about it, it's like 2x and then a function. So this can actually allow us to use the product rule. So how does the product rule work? 2x, you can take the first term derivative and then remain the second term plus remain the first term, take the derivative of the second term. In that case, it's going to be dy upon dx. And that's it. And same thing goes to here. Let me just write this. Same thing here. I can d dx of 3y squared. So how do I do it? You think about it. I have an equation. I have some function here. And then I'm doing like this. So you realize that it's allowing you to actually use something called chain rule. So how does chain rule work? You take 6 here, differentiate inside. So 6y then multiply by y prime. Or since I'm using dy dx, then I'll just write dy upon dx. So in that case, d dx of a constant is always 0. This is a rule that everyone should know by now, hopefully. And so what I'm gonna do, I'm gonna simplify it. So I'm gonna take 2x plus 2y. Hold on, I think I'm running out of battery. Hold on a second. Hold on. Alright, sorry. I forgot to charge it. Yeah, hopefully it can last a bit longer. Alright. Anyways, so I have 2x. I have 2x plus, hold on, alright. 2x plus 2y plus 2x dy dx plus 6y dy dx equals to 0. Remain the dy dx's, put it one side, put this one, put it to the other side, so you have 2x dy dx plus 6y dy dx is equals to negative 2x minus 2y. So from here it's just basic hold on, let me see if I can. Oh, okay. So from here you can say that dy dx, factorize it out, remains 2x plus 6y is equals to negative 2x minus 2y. So therefore dy dx is equals to, factorize the negative out, 2x plus 2y over 2x plus 6y. So if you want to simplify, you will become negative x plus y over x plus 3y. Final answer. So it says that show that the equation is this. So what you're gonna do, you're gonna sub 5 negative 1 in this equation. So when x and y is equals to this, dy dx is equals to negative 5 minus 1 over x is 5 minus 3. So it's going to be negative 2. So it wants the normal, so you have to know that the equation of tangent, if you multiply by equation of normal, is going to be perpendicular to each other. So your gradient of the normal is basically equals to negative 1 over 2. Oh, sorry, 1 upon 2. Alright. So I have this coordinate 5 negative 1, and I have this. You can find the equation already. Y minus 5 is equals to 1 over 2 x minus 5. Sorry, what am I doing? Plus 1. And then simplify, you will get y is equals to 1 over 2x minus 5 over 2 minus 1 is minus 7 over 2. So from here, it was in this form, you can actually multiply 2 from both sides, so to get rid of the denominator. So get rid of the denominator, so you will get 2y is equals to x minus 7. So rearranging terms, you realize that x is equals to 2y plus 7. and show. Alright, so let's look at the next question. So let me just scroll down. So it says that find the exact coordinates of the point where the normal meets C again. So we have two equations. We have x squared plus 2xy plus 3y squared is equals to 18 as my first equation. X is equals to 2y plus 7 as my second equation. So sub 1 in 2. Actually 2 in 1. Yeah. So you will get, sub it all, 2y plus 7 square plus 2y plus 7 plus 3y square is equals to 18. Simplify. 4y square plus 28y plus 49 plus 4y square plus 14y plus 3y square is equals to 18. So put in one side, you will have 11y squared, and then 11y squared plus 42y, and then minus 18 is plus 31 is equals to 0. So now you factorize it. So I'm a bit lazy. Hold on. So you have y minus y plus 1. This one. You will have 11y plus 31 is equals to 0. Y equals to negative 1. Y is equals to negative 31 over 11. So y equals to negative 1, we already know x is equals to 5. So when y equals to negative 31 over 11, so your x is equals to, sub in the value, 2 negative 31 over 11 plus 7. So x is equals to negative 62 over 11 plus 7. So 49 plus, plus 77, you will get so negative 62 over 11 plus 7, I think you'll get 15 upon 11. So therefore the coordinate is going to be 15 over 11 and negative 31 upon 11. That's the point of intersection. So let's see again the implicit differentiation. So I know it's quite challenging, but basically it's not like a normal differentiation, it's like a horror differentiation. You have to think of y as a function. So when it comes to implicit, you have to always remember it's going to be either product rule or is going to ask you chain rule. That's all you can ask when doing the y one with the y together. So yeah, I think that's all. So hopefully you have an understanding of implicit differentiation. So if you still don't understand, maybe I'll make another video on how to do it. So today is just a brief through, and I found this question and I realized it has implicit differentiation. And yeah, an interesting question as well from a pre-U Cambridge Maths question. Alright, so that's all for today. Alright, bye.